In this example, we are going to find the dimensions of a box with the smallest surface area, whose volume is 125 cubic centimeters, and all sides of the base have the same length. So let's get a picture. We are going to draw, it's a box, so we need a rectangular prism. Okay. There we go. And now everything we need is to read carefully what are the specifications for this box. So the first thing we know is that the volume is 125 cubic centimeters, and we know that all sides of the base have the same length. Let's take out this parenthesis, it's confusing. So that means that the sides of the base are both the same length, x, and then the other important feature here is the height that we call y. Okay, and then with this information, we know that the volume is going to be x squared times y, the volume of the base times the height. Now, here we want the smallest surface area. So what is the surface area in the case of a rectangular prism? So we need to account for the area of all the faces, okay? So we have 6 faces, but these have different surfaces, okay? So we need to be a little careful with that. Let me create some space. Okay, so what is the surface area? So we have the area of the base, okay, which is x times x, and we have the base and the top that have that precise surface area, so we need to account twice for it. And then we have the surface of the sides, okay, the side faces. All of them have a surface that is x times y, and there are 4 of them, so it's plus 4xy. Okay, so we have again 2x squared. This is the bottom and top, and the 4xy are the walls or sides. Okay, so we are all set. We know already what are the important variables. We know what is the function we want to minimize. Now the only thing is that the function depends on x and y, so we need to get rid of one of them. We are going to use this condition here. So y equals 125 divided by x squared. Okay. And then with all these conditions, we have that the surface area as a function of x equals to x squared plus 4x times 125 divided by x squared. And there is a cancellation there, 2x squared plus 1000 divided by x. 500 divided by x. All right. So we already have the function we want to optimize, and we just need to compute the critical numbers. So the derivative is 4x minus 500 divided by x squared. We want this equal to 0. That will be if and only if 4x equals 500 divided by x squared. So 4x to the power 3 equal to 500. Okay, that means x to the power 3 equal 500 over 4, which is 125, which is 5 to the power 3. Okay, so we get x equal to 5. And this part is done. And then once we know what is x, we need to say what is y. So this is going to be 125 divided by 5 squared. That's 125 divided by 25, which turns out to be 5 also. Okay, and one last thing that we need to check, we need to make sure this we found is a minimum of the surface area. So for that, we need a sign chart. Okay, x equals 5. And then let's see. So we have s prime of x equal 4x minus 500 divided by x squared positive. That means 4x bigger than 500 over x squared. That means x to the power 3 bigger than 125, and that means x bigger than 5. So s prime is positive on the left of 5. That means is increasing, and it will be negative otherwise. You can repeat this same computation with a less instead of a bigger than. Okay, and you will see that s prime is less than 0 for x less than 5. And then here what we get is that s is decreasing. So we have decreasing before, increasing after. That means x equal 5 is the local minimum. Okay, so that's it. We have that a cube actually minimizes the surface area when you want a box with these characteristics. Okay, like fixing the volume to be 125 and having a square base.